All right, let's get into it. Number 10. The dark energy that's losing its grip. You are a data analyst sitting inside a control room at Kitt Peak National Observatory in Arizona. The year is 2024. On the monitor in front of you, a three-dimensional map of the cosmos is assembling itself. 14 million galaxies rendered as pinpoints of light, stretching back 11 billion years into the history of everything. The map is the most detailed census of the universe ever attempted. It is beautiful, and it is telling you something that should not be possible. The Dark Energy Spectroscopic Instrument, DESI, is the most ambitious cosmological survey ever built. Its robotic fiber optic array can capture the spectra of 5,000 galaxies simultaneously, mapping the expansion history of the universe by measuring baryon acoustic oscillations, the frozen sound waves from the early cosmos that serve as a cosmic ruler. In April 2024, the DESI collaboration released its first cosmological analysis. In March 2025, it released its second dataset, 3 full years of observations, nearly doubling the galaxy sample to 14 million objects and more than 800,000 quasar spectra. The results arrived like a slow-motion earthquake. For 25 years, cosmologists have operated under a single foundational assumption: dark energy, the mysterious force that makes up roughly 68% of the universe and drives its accelerating expansion. That idea is constant. Einstein called it the cosmological constant, lambda, a fixed property of empty space that never changes. It was elegant. It was simple. It anchored the entire standard model of cosmology. And DESI's second data release suggests at 4.2 sigma confidence, that is a 99.995% probability, that it might be wrong. Dark energy appears to be evolving. Its density is slowly declining over billions of years, as if the engine driving the cosmos apart is running out of fuel. The Dark Energy Survey and the Atacama Cosmology Telescope have independently found compatible hints. The signal is converging from multiple instruments, multiple methods, multiple datasets. Think of it this way. Imagine you are riding in a car that has been accelerating for billions of years. You have built your entire understanding of the road, the destination, the arrival time, on the assumption that the gas pedal is locked in place. Now the speedometer is drifting downward. Not crashing, just fading, barely perceptible. But the implications are catastrophic because every prediction you have ever made about where this car is going, the heat death of the universe, the timeline of cosmic expansion, the ultimate fate of every star and every atom, was built on an acceleration that no longer holds. And the most unsettling part is that no one knows what dark energy actually is, constant or otherwise. We named the force that is pushing reality apart. We measured its strength. We built the entire architecture of modern cosmology around it. And now the measurement is changing and we have no theory, none, that explains why. Number 9. The holographic universe. In 1993, physicist Gerard Hooft proposed an idea so radical that even he seemed unsure what to do with it. So Leonard Susskind at Stanford refined it into a precise mathematical framework, and together they gave physics one of its most disturbing propositions: the holographic principle. It states that all the information contained within any volume of space can be fully described by data encoded on the boundary of that region. Not approximately, completely. Every particle, every force, every interaction, all of it reducible to information on a two-dimensional surface. The three-dimensional universe you perceive might be a projection from a flat boundary at the edge of the cosmos. This is not philosophy. It emerges directly from black hole thermodynamics. When Stephen Hawking calculated that a black hole's entropy is proportional to its surface area, not its volume, the implication was revolutionary. The information in our universe scales with surfaces, not with the space they enclose. That is the mathematical signature of a holographic projection, not of a three-dimensional reality. In 2017, a team led by Kostas Skenderis at the University of Southampton published a study in Physical Review Letters, finding substantial observational evidence that our universe is consistent with holographic cosmology. The data from the cosmic microwave background, The oldest light in existence, released 380,000 years after the Big Bang, matched holographic predictions as accurately as standard three-dimensional models. The universe, at its deepest level, may have only two dimensions. The third might be a construct. Imagine standing inside a room you have lived in your entire life. You know every corner, every wall, every piece of furniture. The distance between you and the far wall is something you can measure, something you can walk. Then someone tells you the room has no depth, that every object, every surface, every inch of space between you and that wall is a projection cast from a flat screen you can never see and coded on a boundary you can never reach. Every step you have ever taken was movement across a pattern, not through a volume. The distance between your hand and the screen you are watching right now might not exist in the way you think. Volume itself might be an illusion. You are not moving through reality, you are a pattern shifting across it. Number 8. Wigner's friend and the death of objective reality. In 1961, Nobel Prize-winning physicist Eugene Wigner proposed a thought experiment that seemed, at the time, like an amusing philosophical puzzle. A friend is inside a sealed laboratory measuring the polarization of a single photon. She gets a definite result, say horizontal. From her perspective, the measurement is complete. The photon has a state. Reality has a fact. But Wigner, standing outside the sealed lab, must describe the entire laboratory, friend, photon, notebook, pencil, as a single quantum system. And quantum mechanics says that system is in a superposition. The friend has not measured anything. She is entangled with the photon suspended in a blur of both outcomes, two observers, two descriptions of the same event, both derived from the same physics. And they flatly contradict each other. For decades, this was a thought experiment, a philosophical curiosity filed under interesting but untestable. Then in 2019, Massimiliano Proietti and colleagues at Heriot-Watt University in Edinburgh actually built it. Using 6 entangled photons in a state-of-the-art quantum optics laboratory, they created 2 alternate realities, one representing Wigner, one representing his friend, and directly compared them. The result, published in Science Advances, violated a Bell-type inequality by 5 standard deviations, 5 sigma. The 2 realities were irreconcilable. Both were correct within quantum theory. Neither could be made to agree with the other without abandoning either locality, free choice, or the existence of observer-independent facts. In 2020, a team led by Howard Wiseman at Griffith University in Australia published a strong no-go theorem in Nature Physics, mathematically proving that under reasonable assumptions, observer-independent facts cannot exist in quantum mechanics. We have not found them yet. They are logically prohibited. The theorem's constraints are even stronger than Bell's theorem, the gold standard of quantum non-locality. Imagine you and a friend are watching a football game on the same screen, sitting on the same couch, looking at the same play. You see a touchdown. Your friend sees an incomplete pass. And neither of you is wrong, not because the call is ambiguous, but because the game itself has no single version. There is no referee, no replay booth, no camera angle that settles the question. There are only observers, and each one gets a private reality that is internally consistent, logically complete, and utterly incompatible with everyone else's. That is not a thought experiment. That is what quantum mechanics, tested to 5 sigma precision, says about the universe you live in. There is no view from nowhere. There is no master recording of events. There is only your version and mine, and the mathematical proof that they can never be reconciled. The universe does not have one story. It has as many stories as there are storytellers. And the stories contradict each other. And all of them are true. Number 7. The Boltzmann Brain Nightmare. In the 1870s, physicist Ludwig Boltzmann was studying the statistical mechanics of entropy when his equations produced an implication he never intended. In a universe of sufficient age or size, random thermal fluctuations will eventually assemble any possible configuration of matter, including a fully formed brain, complete with memories, emotions, and the unshakable conviction that it has been alive for decades. The statistics are devastating. It requires far less energy and far less improbable an arrangement of particles to spontaneously generate a single conscious brain in empty space than to produce an entire universe containing that brain. A disembodied mind floating in the void with fabricated memories is overwhelmingly more probable than a coherent cosmos with 13.8 billion years of consistent history. The mathematics say you are statistically more likely to be a Boltzmann brain that formed 1 second ago, complete with false memories of reading this sentence, of waking up this morning, of your entire childhood, than an actual human being in an actual universe with a genuine past. The brain would exist for perhaps a fraction of a second before dissolving back into thermal noise. But during that instant, its conviction of continuous existence would be absolute. You would never know. Imagine a jar of Scrabble tiles. Shake it long enough and you will eventually spell a word. Shake it for the lifetime of the universe and you will spell a sentence. Now imagine shaking it for an eternity. Not billions of years, but a true mathematical eternity. And what forms is not just a sentence, but an entire autobiography, complete with footnotes and an index, convinced it wrote itself. That is a Boltzmann brain. And the mathematics say there should be more of them than there are of us. What makes this problem particularly terrifying is that mainstream cosmology takes it seriously. It is not a thought experiment. It is a genuine constraint in theoretical physics that determines which models of the universe are considered viable. Cosmologists actively reject theories that produce too many Boltzmann brains, not because the concept is absurd, but because those theories would make our observed, ordered reality statistically impossible. Sean Carroll at Johns Hopkins has written extensively about this. Any cosmological model that predicts an infinite future dominated by empty de Sitter space will produce Boltzmann brains in overwhelming abundance. The fact that physicists must design their models of the cosmos to avoid this conclusion suggests the conclusion is dangerously close to the mathematical truth. And here is where it connects to number 10 on this list. If dark energy is evolving, if it is weakening as DESI suggests, and certain models of dynamical dark energy produce dramatically more Boltzmann brains than the standard cosmological constant. The engine losing its grip on reality might also be increasing the probability that reality was never there to begin with. The nightmare is not that you might be a Boltzmann brain. The nightmare is that every test you could run to prove you are not one would itself be part of the hallucination. Number 6. The universe that died before ours was born. In 2010, Nobel laureate Roger Penrose published a theory so audacious that most cosmologists dismissed it outright. He called it conformal cyclic cosmology, CCC, and its central claim is this: the Big Bang was not the beginning. It was a transition. Our universe is just one in an infinite sequence of cosmic cycles, each called an aeon, each ending in a heat death so complete that the distinction between infinitely large and infinitely small dissolves, and a new Big Bang ignites from the ashes of the old. The mechanism relies on conformal geometry. When all massive particles eventually decay into radiation, when every black hole has evaporated, when all matter has dissolved into photons, the dying universe loses its sense of scale. An infinitely expanded, infinitely cold cosmos becomes conformally identical to the tiny, hot, dense state of a newborn universe. The end and the beginning are mathematically the same surface. Penrose and colleague Vahe Gurzadian at the Yerevan Physics Institute claim to have found evidence buried in the cosmic microwave background: concentric rings of anomalously low temperature variance, which they interpreted as gravitational wave echoes from black hole collisions in the previous aeon. In a 2018 paper, they went further, identifying what they called Hawking points, anomalous hotspots in the CMB that could represent the final Hawking radiation signatures of supermassive black holes that evaporated before our universe existed. The evidence remains fiercely contested. 3 independent groups reanalyzed the Planck and WMAP data and found the claimed patterns were consistent with statistical fluctuations in standard lambda CDM simulations. A 2024 analysis using machine learning, a ResNet 18 algorithm specifically trained to detect Hawking points, also found no statistically significant signal after correcting for anomalous bright pixels. But Penrose has never retracted the theory, and CCC's mathematical architecture remains internally consistent. The absence of a clear signal in current CMB data does not disprove the model. It may simply mean the signatures require higher resolution measurements to extract. Imagine walking along a beach and finding a seashell buried in the sand. Someone tells you the shell is not from the ocean you see in front of you. It is from a previous ocean, one that evaporated so completely that its atoms were recycled into the water and sand you are standing on. The shell is a fossil from a world that was erased, and the only trace it left is a faint pattern embedded in the birth cry of the world that replaced it. That is what Penrose believes is hidden in the cosmic microwave background, the fingerprints of the dead pressed into the skin of the living. Number 5. The Axis of Evil. In 2013, the European Space Agency's Planck satellite produced the most detailed map ever created of the cosmic microwave background. The residual glow from the universe's infancy, emitted when the cosmos was just 380,000 years old. The map should have confirmed a smooth, isotropic universe, uniform in all directions. Instead, it revealed anomalies that have been quietly troubling cosmologists for over a decade. The universe appears to have a preferred direction. Large-scale temperature patterns in the CMB align along a specific axis in ways that the standard cosmological model cannot explain. Cosmologist Kate Land at Oxford gave this alignment a deliberately provocative name: the Axis of Evil. The probability of this occurring by random chance in a truly isotropic universe is less than 1 in 1,000. The Planck data also revealed a hemispherical asymmetry. One half of the sky shows slightly stronger temperature fluctuations than the other. And lurking in the southern galactic hemisphere is a cold spot spanning approximately 1.8 billion light-years that lacks any conventional explanation. No supervoid large enough to account for, it has been convincingly detected. These anomalies share a chilling implication. They suggest the universe has large-scale structure where no structure should exist, patterns imprinted on reality itself, pointing toward boundary conditions or architectural constraints that have no place in standard physics. In a randomly generated physical universe, isotropy is the default expectation. In a constructed or computed reality, the kind of directional preferences and hemispherical asymmetries that Planck revealed would be precisely the artifacts you would expect from a system with finite boundaries, rendering priorities, or structural seams. It would be like finding the edge of the wallpaper in a room you were told had no walls. The most disturbing part is not the data, it is the silence. Rather than treating these anomalies as evidence that current models are incomplete, most cosmologists categorize them as statistical curiosities and move on. The axis of evil has been known for over a decade. The cold spot has been studied extensively. The hemispherical asymmetry has been measured with exquisite precision. And yet, no mainstream theoretical framework accounts for any of them. They sit in the journals unexplained, largely undiscussed, and quietly terrifying. The alternative, that the universe exhibits signatures of artificiality at the largest observable scales, is a conclusion mainstream science is not prepared to confront. So it does what science often does when the data is too uncomfortable. It changes the subject. Number 4. The fine-tuning problem. The universe runs on approximately 26 fundamental constants. Numbers like the gravitational constant, the mass of the electron, d, and the strength of the strong nuclear force. Not one of these values can be derived from first principles. They appear to be set arbitrarily as if someone picked them from a menu, but change any of them by fractions of a percent and reality collapses. If the cosmological constant were different by 1 part in 10 to the 120, no galaxies would ever form. If the strong nuclear force were just 2% stronger, hydrogen could not exist. And without hydrogen, there are no stars, no water, no organic chemistry. If the ratio between electromagnetic force and gravitational force shifted by even a tiny margin, no planet could sustain complex chemistry. Roger Penrose calculated the probability of the universe having the precise low-entropy initial conditions necessary to produce observers like us at 1 in 10 to the power of 10 to the 123. That number has more digits than there are particles in the observable universe. It is not a number that emerges from randomness. It is a number that emerges from selection. Imagine waking up in a hotel room you have never seen before. The temperature is exactly 72 degrees. The pillow is the precise firmness you prefer. Your favorite song is playing on the radio. The coffee on the nightstand is the exact brand, the exact temperature, the exact amount of cream you always use. One coincidence, you dismiss. Two, you notice. But 26 independent variables, all calibrated to hundreds of decimal places. I'm all perfectly optimized for your existence? That is not luck. That is not hospitality. That is engineering. The multiverse explanation says there are infinite hotel rooms and you happen to be in the one that suits you. A designer says someone built it for you, but a simulation says the parameters were input values, typed into a configuration file before the program was executed, the way a game developer sets gravity, friction, and air resistance before hitting play. And the question the fine-tuning problem forces is not who made this room. The question is, what do they want from me? Number 3. The quantum eraser and the rewriting of the past. In 1801, Thomas Young performed the double-slit experiment and observed something that physics still cannot fully explain over 2 centuries later. Particles fired individually through 2 slits create an interference pattern behaving as waves when unobserved. But the moment a detector measures which slit the particle passes through, the interference vanishes. The particle behaves as a particle. Reality appears to change its fundamental nature based on whether something is watching. That was disturbing enough. Then in 2000, Yoon-Ho Kim and colleagues at the University of Maryland, Baltimore County, built an experiment that made it worse. The delayed choice quantum eraser. In this setup, entangled photon pairs are generated via spontaneous parametric down conversion. One photon, the signal, hits a detector screen. The other, the idler, travels a longer path to a set of beam splitters and detectors that either preserve or erase the which path information. The critical detail, the idler photon arrives at its detector 8 nanoseconds after the signal photon has already been recorded. The choice to erase or preserve is made after the signal photon's position is locked. When the idler's which path information is erased, the corresponding signal photons, already recorded, already measured, already passed, show an interference pattern in their correlations. When which path information is preserved, no interference appears. The present measurement retroactively determines what the photon did in the past. John Wheeler took this to its cosmic limit, imagining a photon from a quasar billions of light years away, gravitationally lensed around a galaxy. A decision made today on Earth. I could in principle determine whether that photon traveled one path or both, billions of years before our planet existed. The present reaches back through time and rewrites history to maintain consistency with observation. If you wanted to design an efficient simulation, a system with limited processing power, this is exactly how you would build it. You would not render the entire universe in full detail at every moment. You would leave everything in an undefined, probabilistic state until an observer forces resolution. And you would allow the system to retroactively adjust its records when new observations create logical conflicts. A video game does not render the room behind you until you turn around. A streaming service does not load the next scene until you press play. Yet the quantum eraser suggests reality operates on the same principle. And it goes further because it does not just defer rendering, it rewrites the save file. The measurement problem is not a quirk of quantum mechanics. It might be the most important clue we have ever been given. An optimization protocol embedded in the source code of existence. Reality's way of conserving computational resources by refusing to render what nobody is looking at, and cleaning up the timeline when someone finally does. 220 years after Young's double-slit experiment, no interpretation of quantum mechanics fully explains why observation matters. The universe behaves exactly as if it only bothers to exist when someone is paying attention. Number 2. The pixels of spacetime. In 2012, physicists Silas Bean, Zorae Davudi, and then Martin Savage at the University of Washington published a paper proposing a direct, empirical test for whether our universe is a computer simulation. Their reasoning was elegant and unsettling. Any simulation running on a discrete computational grid would produce observable artifacts at the smallest scales, the same way a digital photograph reveals pixels when you zoom in far enough. Our universe has a grid. Planck length, approximately 1.6 times 10 to the negative 35 meters, represents the smallest meaningful unit of distance in physics. Below this scale, the very concept of space ceases to have coherent structure. Planck time, roughly 5.4 times 10 to the negative 44 seconds, is the shortest meaningful duration. Reality is not smooth. It is quantized, divided into discrete, indivisible chunks. These are not just measurement limits imposed by our instruments. They appear to be resolution limits, fundamental boundaries below which the universe simply does not contain information. Bean's team identified a specific observable signature. Ultra-high-energy cosmic rays should exhibit directional preferences if spacetime is a cubic lattice rather than a smooth, continuous manifold. The cosmic ray spectrum would contain imprints of the grid, visible at the highest energies. Preliminary data from cosmic ray observatories showed intriguing patterns, though the results are not yet conclusive. But the deeper question persists regardless of any single experiment. A genuinely continuous physical reality has no reason to exhibit minimum units. Smoothness should extend infinitely downward. There should always be a smaller distance. A shorter interval, more structure at finer scales. The existence of Planck scale quantization is exactly what you would expect from a digital system with finite resolution, finite clock speed, and finite memory. And it has no satisfying explanation in any model that treats the universe as fundamentally physical. The speed of light itself might not be a property of space. It might be a processing speed limit, the maximum rate at which the underlying computation can update neighboring cells. Quantum indeterminacy might not be genuine randomness. It might be computational branching, the system exploring multiple pathways before resolving to a single output. Every feature that makes quantum mechanics strange is also a feature that makes perfect sense in a digital architecture. You are living inside a picture, and somewhere far below the resolution your eyes can reach, the pixels are showing. The question is no longer whether the grid exists. The question is whether the system allows its inhabitants to discover the truth about their own substrate, or whether awareness itself triggers consequences we cannot anticipate. Number 1. The consciousness trap. In 1781, Immanuel Kant argued that space and time are not features of reality, but cognitive frameworks imposed by the mind to organize experience. For 2 centuries, science dismissed this as pure philosophy, interesting but irrelevant to the hard business of measuring particles and mapping galaxies. Then the evidence started arriving from 3 independent directions at once, and the convergence is devastating. In 2019, cognitive scientist Donald Hoffman at the University of California, Irvine published a mathematical proof using evolutionary game theory that struck at the foundation of scientific realism. His fitness beats truth theorem, demonstrated across all possible environments, shows that organisms tuned to perceive objective reality are consistently driven to extinction by organisms tuned to perceive fitness payoffs. Natural selection does not reward accuracy. It rewards utility. Evolution did not design your brain to see what is real. It designed your brain to see what keeps you alive. Every color you have ever seen, every sound you have ever heard, every texture you have ever felt is a species-specific interface. Not a window into objective reality, but an adaptive hallucination calibrated across millions of years to maximize reproductive success. From theoretical physics, Nima Arkani Hamed at the Institute for Advanced Study in Princeton has arrived at compatible conclusions through entirely different methods. His work on the amplituhedron, a geometric structure that calculates particle scattering amplitudes without any reference to space or time, demonstrates that spacetime itself is not fundamental. It is emergent. It arises from something deeper, something that has no location, no duration, no physical extension. Space and time are not properties the universe possesses. They are constructs generated by something we do not yet understand. And from neuroscience, Giulio Tononi at the University of Wisconsin-Madison has developed integrated information theory, IIT, first proposed in 2004 and now in its fourth major revision. IIT argues that consciousness is not a byproduct of neural activity. The consciousness is identical to integrated information, quantified by a mathematical measure called phi. The radical implication: consciousness does not emerge from matter. Consciousness is fundamental, and what we call physical reality is a specific structure of information that awareness uses to model itself. If Tononi is right, then matter does not produce mind. Mind produces the experience of matter. Three independent fields, evolutionary biology, particle physics, and neuroscience, have converged on the same conclusion through completely separate methodologies. The universe you see is not out there, it is in here. Reality as you experience it is an interface, a dashboard, a user-friendly illusion that bears no structural resemblance to whatever actually exists. The desktop on your computer shows folders, files, a trash can. The useful icons, but they look nothing like the voltage differentials and magnetic orientations they represent. Hoffman argues your entire sensory world is the same kind of abstraction, a symbolic overlay that hides a substrate you were never designed to perceive. You cannot look beyond the interface because your consciousness is the interface. Every telescope you build, every accelerator you power up, every equation you solve is processed through the same perceptual architecture that evolution built to hide the truth. You are not discovering reality. You are navigating a map that was never meant to match the territory. And the territory might be something no human mind. No mind shaped by natural selection on a rocky planet orbiting a yellow dwarf star was ever built to comprehend. And that brings us back to every entry on this list. The dark energy that is losing its grip. The hologram with no depth. The observers who cannot agree on reality. The brains that formed from nothing, the universe that died before ours was born. The axis that should not exist. The constants that were engineered. The eraser that rewrites the past. The pixels beneath spacetime. Every one of these anomalies points in the same direction. Reality is not what it appears to be. And the 10 entries on this list are not isolated curiosities. They are a pattern. A mosaic of fractures in the foundation of everything we thought was solid, everything we thought was real, everything we thought was ours. The three most honest words a scientist can say when staring at data that contradicts every model, every assumption, every comfortable certainty are, "We don't know." And right now, standing at the edge of what physics can explain and philosophy can imagine, those three words are the only ones that are true. Sleep well. I'll be sharing more similar videos in the future, so subscribe to stay tuned.